Now today we wanted to discuss the dot products of two vectors. Let us consider that is dot product, or sometimes it is called scalar product. Let us consider two vectors A and B, okay, and consider it is A vector and it is B vector, and angle between these two vectors is theta. Then the dot product of the vector A and B, it is denoted by A dot B, and it is equal to mod A mod B into cos theta. It means the dot product of two vector is always a scalar quantity. If A vector and B vector are perpendicular, then theta is equal to pi by 2. So A dot B, it is equal to mod A mod B cos pi by 2 equal to 0. That is, when two vectors A and B are perpendicular, then their dot product is 0. Sometimes if two vectors are perpendicular, it is also called perpendicular, means it is also sometimes called orthogonal vector. And we know that I cap is a vector along x-axis. Consider this is the first octet of three-dimensional plane where we consider x-axis, y-axis and z-axis. We know that I cap is a unit vector along x-axis, j cap is the unit vector along y-axis, and k cap is the unit vector along z-axis. And we also know that the angle between out of these three unit vectors, any two unit vectors, angle between any two unit vectors is 90 degree. That is, they are mutually perpendicular. Therefore, I cap dot j cap or j cap dot I cap, it is 0. Also, j cap dot k cap equal to k cap dot j cap equal to I cap dot k cap dot I cap. Okay, so these are 0. Here we write that I cap dot j cap and j cap dot I cap, because the dot product hold commutative property. Therefore, dot product is commutative. Or simply you can say that A dot B is equal to B dot A. It is called commutative property. Also, the angle between I vector and j vector is 90 degree, but angle between I vector and I vector is 0 degree. For that reason, we can write down I cap dot I cap, j cap dot j cap, and k cap dot k cap is equal to 1, because I cap dot I cap means mod I cos 0 degree, that is equal to 1. In similar manner, you can prove that I cap dot I cap, j cap dot j cap, k cap, all are equal to 1. Also, one thing is, we always remember that A vector dot A vector mean mod A cos 0, that is A dot A, it is equal to mod A square. Also, dot product satisfies some distribution properties, and as for example, A dot B plus C, it is equal to A dot B plus A dot C. It is called left distribution property. Similarly, we can consider the right distribution property as follows: A plus B dot C vector, it is equal to A dot C plus B dot C. It is right distribution property. Now we talk about the thing that how we evaluate a dot b, where a vector is, that is, a vector is given in the form of I cap, j cap, k cap, and b vector is given in the form of I cap, j cap, k cap. That is, if a vector is equal to a1 I cap, a2 j cap plus a3 k cap, and b vector it is equal to b1 I cap, b2 j cap, b3 k cap, then a dot b it is equal to a1 b1, a2 b2 plus a3 b3. Now we can easily prove the this formula. We can easily prove that this formula and yeah, a dot b. Okay, a dot b mean a equal to this I a1 I cap, a2 j cap plus a3 k cap dot b1 I cap plus b2 j cap plus b3 k cap. Now we first multiply this whole expression by a1 I cap. Then it will be equal to a1 I cap dot b1 I cap, b2 j cap, and b3 k cap. Similarly, a2 j cap dot here a1, a2, a3, b1, b2, b3 all are scalar quantity. Plus a3 k cap equal to b1 I cap plus b2 j cap plus b3 k cap. It is equal to a1 b1 I cap dot I cap. Here we consider a1 b1 mean it is a normal multiplication, scalar multiplication, that is I cap dot j cap a1 b3 I cap dot k cap plus a2 b1 j cap I cap, then a2 b2 j cap dot j cap plus a2 into b3 j cap dot k cap plus a3 into b1 k cap dot j cap I cap plus a3 into b2 k cap dot j cap plus a3 into b3 k cap dot a cap. Here we know that I cap dot j cap, I cap dot k cap, j cap dot I cap, j cap dot k cap, k cap dot I cap, k cap dot j cap all are 0 because they are orthogonal to each other, and I cap, j cap, and k cap, all are 1. Therefore, after simplifying this, we get a1 b1 plus a2 b2 plus a3 b3. That is, when two vectors are given in the form of I cap, j cap, and k cap, we can easily derive their dot product using this formula. Next, we try to understand the um, the dot product between two vectors by a suitable examples. Consider two vector, a vector equal to I cap plus 2 j cap plus 3 k cap, and b vector equal to minus 2 I cap plus 2 j cap minus k cap. Then if a and b given in this way, our first target is to evaluate, find a dot b and the angle between a vector and b vector. Since a vector is already given, therefore mod a equal to square root of 1 square, 2 square plus 3 square, that is square root of 1 plus 4 plus 9, which is equal to 14, and mod b vector equal to square root of minus 2 square plus 2 square plus minus 1 square. It is equal to square root of 4 plus 1 equal to 3. Also, a dot b, our first target is to evaluate a dot b. We know that a dot b is equal to 1 into minus 2, that is the coefficient of I cap is 1 and coefficient of I cap here is minus 2. We multiply them. Then we also multiply 2 into 2, that is equal to plus 2 into 2. Then plus we multiply 3 into minus 1. After simplification, it become minus 1. Therefore, a dot b equal to minus 1. Now we evaluate the angle between these two vectors. We know that a dot b equal to mod a mod b cos theta. This implies that cos theta equal to mod a mod b divided by mod cos theta equal to a dot b divided by mod a mod b, that is equal to minus 1 by root over 14 into 3, which implies that theta is equal to cos inverse minus 1 by 3 root under 10. This is the angle between these two vectors. Now I wanted to discuss some geometrical meaning of dot product. It is actually geometrical meaning mean we want to projection of a vector on B. We can understand the projection of the vector A on B using dot product. Okay. Try to understand projection of A. So it is actually geometrical interpretation of dot product. Consider it is O and this point is A, and also consider it is B. It is B. Let OA vector equal to A vector and OB vector is equal to B vector. Also we consider angle between these two vectors is theta. Now the projection of, to evaluate the projection of the vector OA on OB vector, OA mean it is A vector and it is B vector. We draw a perpendicular from the point A on the vector OB. So it is perpendicular, it is 90 degree, and we consider the foot of the perpendicular is P. P is the foot of the perpendicular. Therefore, here length of OA, so it is actually OA mean mod of OA mean hypotenuse, because this angle is 90 degree. Okay, and the projection here OP and here OP is the base of the triangle. That is here triangle OAP is a right angle triangle. Right angle triangle where angle APO equal to pi by 2. Here OP is equal to hypotenuse and OP is equal to base with respect to the angle theta. Therefore, OP by OA equal to cos theta. This implies that OP equal to OA cos theta, and OP equal to, we know that OA mean mod A vector and cos theta. Consider it is equation 1. Since the angle between the vector small a and small b is A theta, then therefore A dot B is equal to mod A mod B cos theta. This implies that mod A cos theta, it is equal to A dot B by mod B. We know that mod A into cos theta, it is equal to OP, and A dot B cap. Here we consider B cap mean unit vector of along B, that is B by mod B. So this is the projection of the vector. This is the projection OP of the vector A on the vector B. It is just to evaluate the projection of A on the vector B, we take the dot product of A and the unit vector along B. Now we solve one problem where we have to evaluate the projection of a vector. That is, in previous example, we already consider two vectors A and B. Now we take these two vectors. Now we consider these two vectors. To evaluate the projection of A on B, we find first, to evaluate the projection of A on B, we first evaluate mod A. It is already we have evaluated. Mod B is equal to, sorry, we evaluate mod B. Mod B is equal to 3. Okay, mod B equal to 3. Therefore, B cap, next we evaluate B cap. B cap equal to B vector by mod B. B cap mean unit vector along B. Okay. Therefore, the projection of A on B vector, it is equal to A vector dot B cap, mean A dot B vector by mod B vector, and A dot B also we evaluated A dot B. A dot B is equal to -1, is -1, and mod B is equal to 3. So this is the projection, -1 by 3. Uh, since projection mean it is one type of length, therefore we consider the positive value only, that is absolute value of this. Okay, that is the answer is, that is projection is only 1 by 3 units. Okay, in the next class we discuss about cross product of two vectors in the next upcoming lecture. Thank you students, and